Welcome to This Explainer. Today, we're diving straight into the absolute bedrock of our future, semiconductor engineering. If you're wondering where the literal bleeding edge of career opportunity is hiding right now, well, you've found it. We're going to break down the macro trends, the data, and the very specific pathways that are opening up right now in this massively booming sector, all based on our source material. So think about this for a second. What actually powers the modern world? The engine of our entire global society isn't some massive, sweeping thing. Actually, scratch that. It's completely microscopic. The modern world is entirely 100% dependent on silicon. Without it, everything just stops. And I mean literally everything. The source material we're looking at today highlights exactly how foundational these little components are to our entire way of life. Okay, let's get right into it. Semiconductor engineers are basically the ultimate bottleneck for all the transformative industries we hear about every day. Take smartphones, for instance, constantly pushing the absolute limits of microscopic thermal management. Then you've got electric vehicles, where incredibly complex chip architecture is handling everything from high-voltage battery management all the way to autonomous driving systems. Next up is artificial intelligence. The demand for unimaginable processing power here is vastly outpacing the supply right now. And finally, data centers, which require massive efficiency upgrades just to handle the sheer volume of global computation. Every single one of these trillion-dollar sectors relies completely on the engineers who create their chips. So what does this work actually look like day to day? Well, the source outlines this really fascinating four-step life cycle. First step is design, which means conceptualizing microscopic pathways and logic gates. Second is manufacturing. This is where you're executing highly complex fabrication processes on a massive scale, usually inside extreme cleanroom environments. Third, you've got testing, pushing these chips to their absolute limits to ensure zero-fail reliability. Because hey, whether that chip is sitting in a server rack or, a pacemaker, it has to work perfectly. And finally, improvement. It's this continuous, never-ending iteration loop to drive smaller, faster, and more power-efficient architectures. This whole cyclical process is exactly what keeps technology moving forward. Now, we are witnessing a monumental macroeconomic shift right now. U.S. companies are pouring unprecedented amounts of capital into domestic chip production. The decades-old narrative of offshoring, that has completely flipped. We are seeing a historic push to bring semiconductor manufacturing right back home. The sheer scale of this investment is honestly staggering, as companies are practically racing to secure their supply chains and build state-of-the-art fabs right here on domestic soil. We're talking about a fundamental restructuring of a massive global industry. And that massive domestic investment brings us to the core takeaway of this entire explainer. Because of this massive push for domestic production, the demand for skilled engineers is just exploding. Think about it. You can build all the multi-billion-dollar manufacturing plants in the world, but they are totally useless without the human capital to actually run them. The industry has the funding, they have the mandate, but their absolute biggest hurdle right now is finding the talent. They need you. This represents a massive window of opportunity. It means incredible leverage, rock-solid job security, and the chance to be at the very forefront of a vital global priority. And the cool thing is, being a semiconductor engineer isn't just one single job. It's an entire ecosystem of highly specialized, supercritical roles. Our source breaks down all these distinct paths. You have semiconductor design, where you're actually architecting the chip itself. Process engineering, where you figure out exactly how to fabricate those designs flawlessly at a massive scale. Reliability engineering ensures these components can actually survive harsh, real-world environments. Field service puts you right on the front lines, managing incredibly complex equipment. Testing, as we mentioned, is the ultimate quality control. Then there's automation, which is a huge field right now, programming the robotics that handle the tech. And systems engineering brings the whole shebang together, looking at the big picture of how all these parts interact. Basically, there's a place in this ecosystem for almost every type of analytical mind. Okay, so looking at that list of high-impact roles, how do you actually get there? If you're a focused learner, looking to pivot your career or advance to the next level, what's the price of admission to this booming sector? What exactly are these employers looking for? Let's break down the foundational knowledge you need to architect the future. Employers in this space are aggressively hunting for candidates with experience in a few core technical fields. Think of it as an alliance of sciences coming together. Engineering, of course, provides that crucial structural problem-solving mindset. Physics is absolutely non-negotiable because when you're working at the nanometer scale of a modern microchip, you are dealing directly with quantum mechanics.
Computer science is essential for designing the logic arrays and the automation software. And finally, material science, because the physical silicon itself, the chemical etching processes, and the thermal properties totally dictate what the chip can actually do. Building a modern chip requires a convergence of all these disciplines. So, if you have a background in literally any of these areas, your skills are highly transferable and intensely needed right now.
We've talked a lot about the domestic manufacturing boom, but where is the concrete actually being poured? Where are these jobs geographically clustering? Well, the source material points out exactly where leading tech companies are aggressively expanding their footprints right now.
These are the epicenters of the domestic chip revolution. Beyond the established titan of Silicon Valley, you have Portland stepping up as a massive player in research and development. Phoenix is experiencing an absolute explosion in infrastructure and fabrication plants as we speak. Austin continues to grow its dominance as a major tech stronghold. And get this, upstate New York is rapidly transforming into a premier hub for next-generation chip manufacturing. What this tells us is that you have options. Leading tech companies are expanding across all these distinct regions, meaning you can find a world-class engineering role in a part of the country that actually suits your lifestyle.
The industry needs talent like yesterday, and the expansion is happening right now across the country. The technical roles are incredibly diverse and absolutely vital to powering everything from EVs to AI. So if you're ready to step into this space, the source gives us a very clear, practical next step. Explore the latest semiconductor engineering jobs with USA Tech Recruit. Connecting with specialists who actually understand the deeply technical nuances of this specific industry is without a doubt your most efficient way to navigate the transition into this field.
We're going to end on this thought. The microchips being designed and built today are literally going to define what humanity is capable of tomorrow. The demand is there, the investment is there, and the opportunities are mapped out across multiple technical disciplines and geographic hubs. The only missing piece of the giant puzzle is the talent required to make it all happen. So, are you ready to architect the future? Think about how your skills align with this incredible industry. Thanks so much for joining me for this explainer.